They were right in their own minds. No, they were right. I'm like, you can't be preaching more relativity and say that these people are
wrong or right, exactly. I might want to throw in a new slide here. Or I'm recording. I don't know which I'll do.
Wait, what? Why?
I don't really need a new slide. Okay, let's get rid of that. Let's go on. Okay, guys.
Wait, so what's heat diffusion?
What's heat diffusion? Okay, I want to make sure we're all clear about something here, okay? Yeah, I'm getting there. Okay, so, I would not mess with, you know what? Since I'm in here, let me bring this up because I can't write on it when it's like this, and I can if I go in here. The whole reasoning for having one of these is so that I can write on the top. Okay. So let me bring it up where I can write on it, okay? Okay, so, down here, when everything comes up, put it on pen. Okay, guys. First, let's make sure we're all up on this equation, okay? So, this is, think of, since this K is out here, think of it like this, okay? So make sure your equation is right. Make sure that this is delta T right over C delta T. Because you're not, this is not being tested on math, okay? You're really not. It's a CS class. But I do like to give you these kinds of things. Mainly because what I'm trying to get you to understand right? You know, I'm not going to write it nicely for you. So I want you to really understand, too, that when we get problems from people, they are not computer scientists. Because they would have done it on their own. Our problem statements and our problems do not come from a computer scientist, typically. Okay? They're coming from somebody with a business degree, depending on if they're running a company, you know, Fortune 500 or something, and they just have ideas, right? I mean, some may be knowledgeable, but, and sometimes maybe you're doing something for the sciences and stuff like that, and they give it to you in these terms. If you were to go out there and look up explicit heat diffusion, you'll see that it's very common to see it written like this. It is not me making this up, okay? I'm giving it to you like this so that you can understand when you are given a problem like this from somebody, how are you going to put it in CS terms? That's your main thing, okay, is you have to think of how am I going to take this and put it into the way that I can express it in the computer. And you don't have anything that looks like a U to the T with a subscript, right? You don't have superscripts and subscripts and things like that, right? But you do see that, hey, this is all common here, and this is different, and then we do have a way to get to the space, right? And so you things like that, you start coming up with, how am I going to represent not this part of it, but this part of it, because I see a pattern in here, and I see a pattern right here, right? And so to me, I'd call these different things. This is all kind of the same terms, right? And so I'd have it a name of something. So you got to look for patterns. You really do. And so I like these kind of problems because I want you guys to think that you're not always going to get stuff from a computer scientist. You're going to get stuff written in terms that you're going to have to figure out how to put it into a CS program. The other thing that I'm trying to get at with you guys, and I subtly put things out there like this and say, you know, read information from this, put your file name out to this. Some of you will name it that, some of you won't name it that. Some of you will read it, some of you won't read it. So I'm trying to see how well will you read, what will you do with testing, how do you know you're correct? That's what I'm trying to get at with this, is how do you know when you're correct, okay? And it's easy to know with textual data if you're correct. If I were to give you this and say, print this, you know, read from a file, and then print the binary values to this, and that's all I told you to do, and I didn't give you any information, that's what you guys would do, and I'm not sure what you would do to know whether or not you were correct. And even if you spit out the textual data, okay, this looks correct, and you could do it by hand or do it in the calculator and make sure you're correct, that the calculation being done in the computer is one that would be right by hand, and that's how you could go about that. Hence, that's what this is, okay? That's why I do this, right? So this is me making sure, is my calc correct? Okay? Because that's the first thing you got to make sure is correct when you're testing something. All right? This is based on me reading this data. I gave this data to you. Okay? I've seen some people in my office coming up with their own information in here. You're not going to have this same stuff down here, and how are you going to know you're correct if you're not putting something in there to, I'm giving you a test case. I'm giving you a, how can you see if you're correct? If you match me, you're correct. Okay? Now, once you were to push this out into a binary file, you can't read a binary file. How are you going to know you're correct?
Put it into the program to see.
That's why I gave you grads to look at it. I was sitting in the office with somebody today, and it's funny when I say it in this way that it makes more sense on why you would do this. Say you're working for Microsoft, okay? You write Microsoft Word, okay? You're going to make sure that people can put in textual data, they can make it bold. You can see that it's working correctly or not, but you're testing it to make sure all that functionality is working correctly. That's this kind of functionality. Next thing you have inside of Microsoft Word is, think about many times we push stuff out, we save things as a GIF, we save things as a PDF, we save things as, it's a functionality that's been added to Word, right? Programmers had to add that functionality in there. Okay? So what would you do in the situation if you're working for Microsoft and now your boss says, I need the functionality to save this file as a PDF? It's going to be spit out as a binary. You can't read that binary to see, is that result correct? Can you? No, a PDF is binary. You can't read it. Go try to read it. Open it up with some text editor. You can't read it. So what do you bring it up in? What would you do? You would bring up the Acrobat Reader and you would view that binary to make sure, does this match what the word text is? Hence, that's this part. I'm trying to get you to understand that there's several places you have to know whether you're correct. You can't just go spitting out binary and go, oh yeah, just because it was correct like this, it's correct down here. No! What if you're spitting it out in the wrong direction? What if you spit out a GIF and you don't go check it, and your algorithm for when you print out that binary is going in reverse order? Somehow or another you've gotten your, you know, your X and Y's mixed up, and now things are all flipped. That picture's not the same picture anymore. And if you didn't go and look at it, how are you going to know that? You wouldn't. You have to check at every stage what you're getting back is correct. With this type of result, with this type of program, you need to make sure two things are correct. You have to make sure, am I getting the correct calculation? Is this right here set up correctly? The next thing you have to do, once you know out to the screen you're getting this, then you need to go and push that into a binary file. To know whether that binary file is correct, That's why I gave you this idea to look at it, okay? Now, with that said, well, over the weekend you're all trying this, okay? Don't muck with these. Use these, because otherwise you're not going to know if all of this is correct. You're messing with things, okay? I gave you this because I'm doing 50 time intervals. Notice this is nickel. I'm doing this based on nickel. That's why my time instance, if I had to look at nickel every second, I wouldn't see the heat would already be diffused. Nickel moves too fast, okay? If you want to muck with things, be my guest on mucking with things, okay? But at the same time, make sure that you understand what you're looking at, okay? Down here, you've got properties. If you want to be adventuresome and you want to play with stuff, take a gander at copper. Copper's thermal conductivity, well higher. It's not going to diffuse as fast. You can make your seconds smaller, okay? But you can't think that messing with these things, it took me a while to figure out something that was acceptable for you to have that would give you some data, decent. Okay, if you start messing with this, you're gonna get some crazy stuff back. Okay. So these are all that came from the nickel properties that I looked up. You read all of these. You read, make it 30, okay? Do 30. 50 time intervals, and I'm going at very small amount of time because nickel is highly conductive, okay? Or it goes fast, right? Not conductive, I guess. So then down here, because I'm getting these questions a lot, make sure is a capital. So another part of this is testing, reading. Can you follow directions? Can you read? This is a capital Y. It's not a lowercase y. Make sure you use a capital Y. You won't see anything. Okay? Make sure that's capital Y right there. If you're a Mac user, okay? If you're a Windows user, just go into your PuTTY and do this one, all right? These files, okay? Don't mess with them. As long as your stuff up above is the same as mine, use these. Where's my little pointer? Okay? This is saying you have to, a program has to know how to interpret data unless the data is always going to look the same. This is a program where we can model up to 3 dimensions and time, so really up to 4 dimensions, because it'll produce a motion for you over time. And so what this is saying, notice up there, what am I saying to grads? I'm saying, hey, set my data to heat_bin.dat. If you're not pushing your binary file out as that name, this file is not going to work for you. Okay? So the more you start messing with things in this assignment, the worse off you're going to get. Promise me. Or promise you, right? This 30, it's because we had 30 X's. We had 50 time intervals. This is your time. You have an X, Y, Z axis that you're allowed to use in this program, and you have a time 50 intervals. Okay? This is what's called metadata. It's your data. It's the data that describes your data that you're giving to a program, which is known as metadata, okay, in computer science. So this is called a metadata file. We have temps that are ranging from 0 to 99, and that's about that. And undefined. You can look all of this up if you wanted to know more about any of this. I doubt you will, but use this file. And don't mess with things, okay? Use this file, okay? Make sure you save this control, this .ctl, the .gs, and the heatbin.dat, the binary file that you're pushing out. Save them all in the same place, and when you go into grads, when you open grads, be in that directory when you do this. Okay? That's another tip I'm going to give you. Now, you can make them all look in other places, but if you want to do, put them all in the same place for ease of use, and open grads in that folder. And all of this will work together. Okay? This says we have, I'm not really sure why I have to set this Y thingy, 0, 2. Time, we're doing 1 to 50. Map, we do not want the map of the world on here, so I say to turn it off in case you want to know what any of these mean. Looping is on because I want motion. Okay. This metadata is important. It does not matter whether you flush this binary file out all in a row or you put a new line after each one of the times. Okay? It'll work either way. Should. Because this control file, what it's looking at, that's saying 30 X's and 50 time instances, knows when it's read 30 things, that was 1 X, 1 time difference. So whether they're beside each other or whether they're on another row doesn't really matter. We read 30, boom. Do not want this in your binary file. This was for me to know what I'm doing correctly. Grads doesn't give a rat's butt about that thing. Okay? It just cares about these. I think Grads also cares about, so you don't care about that, putting that out in the Grads file, and these need to be floats, not doubles, because it works with a 32-bit. What the heck? Okay. So behind the scenes, because remember, it's reading a binary file. We got to know on bit level what we're reading. It's dealing with floats. Okay. Just wanted to see how much you guys would read, because all that's in, I give you, I'm always just kind of curious how much you'll go out and look at what this package is, what it's about. And you can go look at it if you want. And that's it, okay? Make sure you do this before you actually bring up the Grads. And then this is what you're doing. This is exactly, once you're in that file where this is going to be in the same place. Make sure it opens your heatbin.dat. That's in the same directory. And this, and we're doing this starting Grads in where all those places are. Does that make sense? Okay. I think you have everything now you need to do to be able to do this. Okay? Just don't try to get too tricky. Get tricky after you know the darn thing works, okay? Because if it's working for my input and stuff, then it's going to work for any input. It's the whole bottom line for why we develop algorithms and why we write programs and we test it for this. It should work for any, okay? And if you get this picture, this is your best assignment. If you get this to your screen and you get this as a picture in your Grads, you have 100 on this assignment, period, point blank. Okay? Yep. So you know what your grade is. Now, if you want extra credit, so I already posted this. If you want extra credit, do the two-dimensional one. Watch your complexity. Play with this, guys, okay? Because we already have an n-squared complexity because you have time and you have a space of x, right? Now, if you really want to start talking about this time complexity, now we're getting into a triply nested loop. Now we're talking about an n cubed, okay? Of course, time doesn't have to be the same n as those others, but worst case scenario, they're all alike, right? Equation's not very hard, guys. If you got it right for the other one, you know what a two-dimensional array is. This is now just not a one-dimensional, it's a two-dimensional. Oh, wow, look, we have two brackets. Look, one bracket, another bracket. Oh, my goodness. Look at how easy that was to change this. Okay? So it's the easiest extra credit I think you're ever going to be able to get. If you can get it done for the 1D, this is pretty darn easy for a 2D. Okay? And then you can adjust your Grads file to work with this because now you just need to put that YDEF in there. Okay? I went ahead also down here and put your problem statement so you could start designing for the next assignment, because we will have a test during that time period too, so I want to give you plenty of time to work on it. And so when it releases by next Wednesday, I think you'll have about 2.5 weeks if I make it due on that Friday, right, with a test in there. Am I right? Am I on the weeks right?
Yeah.
Yeah. It's next week's week 8.
It is, okay. Trying to make sure you got 2 weeks to do this and not crunching it at the end. Okay, and then I'll release in Dead Week, at the beginning of Dead Week, I'll release your final project. We don't come to class to do it. You just email it in or you send it in through Teach, and it's just, I'll think of something for you. I haven't thought of it yet, okay? And it'll be due by that next Friday of the end of final exams. Okay? Yeah, no battleship. I am not playing a 200 battleships. Ugh, I'm not doing that again. No, thank you. Probably be something more like a paper. You know, I like to give you, I'm hard on you in the middle of the quarter or throughout the quarter, but I like to be easy on you at the end.
We have the final exam itself, or is it the final?
The final project is your final exam, so I'm just trying to get you caught up on what to do over the weekend. I wanted to release all of this to you so that you had time to do the extra credit and design for the next assignment. Okay? All right. Okay. That didn't sound very reassuring. All right.
Get through this one,
Then you'll let me know.
then I'll
What's the wrong one?
I should get through it the weekend.
Exception, guys. So I'll be really quick about this, and then I'll let you go. Enjoy your day. Maybe go over to the expo. Air handling can be done one of 2 ways. Okay? This is your C way of doing it, non-OO, okay, or non-OOPS for object-oriented programming. So that's your C way of doing this, is you have to check. I have made you do the harder way, okay, because this way can go into any language, all right, can be used anywhere. That is, for instance, before you divide by a number, you check to see if it's 0 before you do the division.
Right.
That's a check before you do it, okay? The other way that you get an object-oriented, okay, is this exceptions, okay? You let the error happen, okay? You don't prevent the error from happening. You let it happen, and then you catch it before termination. So you terminate gracefully. Okay? And you do this by trying something and catching it if it doesn't succeed. It's this easy. You try, you put some crap in here, and then you catch. This is your catch-all. This is for all exceptions. Fall into this category. That's the parent. That is the main one from which all other exceptions are derived. Okay, so there is inheritance in exceptions. Okay, so order matters. Okay, if you're looking for an out of range or in your lab, right, we have one where you're looking for to see if the open failed. If you were to try to catch this exception before a open exception on a file, then you're going to catch something that may not be the one you want to catch with that. Okay, so you basically want, in the order in which you put them in matters, you want to put your furthest up derived class first. And how else to say that? Okay, you want to put the base one as far base or as far down as you're going as the last. Okay, so for an example, I'll show you. And the cool thing is it will give you a warning, okay? So, say for instance we put this in front. Okay? This is what you're doing in your lab. Okay? And name doesn't exist for me. Okay, it's called name.text, or I can't remember what we made it called, okay? And so this is the one from your lab. Now I'm going to, instead of catching it with that testing the open and the fail Remember, you could test the little fail thing and then just say an if. That's doing your just normal how to handle errors, okay? You have this way to say open it. This open is going to throw a failure exception if it doesn't open correctly, okay? If I were to put in here catch exception E, then we should get that rather than knowing we have not a good file exception, okay? So let's and the nice thing is the darn thing gives me a warning. Now that doesn't mean it won't run, right? I'm going to still run this. Why is it not going? And notice I got general except, okay? So I got general except, hit that exception, but I did a warning. Hey, you goofball, you put something below one of the base classes. You put a derived below, and you want to put the derived above, okay? So if we were to change that, oops, where am I? All you have to do is, oops, DD, P, not a good file, okay? So just make sure, order matters. That's kind of a boring topic to teach, to be honest with you. Because it's not, I mean, you know, you've already learned the hard route. This is actually this is the easy route. But I make you do that because for your CS career, once you get into 311 and 261 and the hard class, you're not in C++. You can't try catch. You don't have that ability. And trust me, if you're in one of those classes and you don't handle your errors, you are not going to pass those classes. I promise you that. Now, 311's a pro school class, I get it, but that is going to be your stumbling block. I'll warn you now, unless you haven't heard from friends. You can throw your own exception, okay? So like for a divide by 0, you can throw your own thing. You could do a check, and then you can say throw, and it needs to be a variable or an object, because this is of that same type, okay? So say you made a class, or say you had a variable of an int, then you would put, say you had an int a, you could throw a, and this would be an int, and it would catch that one, okay? If you had a class, remember we got a class a, right? Okay? We can make something of that. If we make a AA, I'm being really sloppy today, then, of course, if you throw A in that situation, then you're catching A. So you can catch of a class type, which is an object, but remember it's just a user-defined type. Just needs to be a type here, whether it's a primitive or whether it's a user-defined. Okay? We won't do a demo on that because I'm about to let you go. All right. Then you can do this, okay? You can also have it to where you do this, you're in a function, okay, and you call the function, you don't throw the error inside or the exception inside of the try, but this thing throws the error, okay? So notice I'm inside of a function throwing an error. I'm not throwing the error in my try. This one before is throwing it in the try, okay? In that case, you say, hey, I have this function, you have some return type, you have a function, and it is going to throw, and you put out however many types it may throw. It may throw several different types of exceptions. It may throw a general exception and a file I/O exception, okay? You need to say, what are those types, okay? One of those would be exception, what we just saw in the demo, and the other one would be failure. Remember? That one came out of a certain place, out of the IO stream. Okay? Does that make sense? And then that thing throws it, and this one catches, and you can have several catches. Now, you can't have several tries. A catch has to follow right below a try. You can have them nested, but you can't have, like, several tries and then a catch. You can throw several things in one try, therefore you need several catches after the try to catch several different kinds of errors, but you can't have multiple tries because it'll throw you an error. It's looking for a try, and after the bracket, it's looking for catch. These need to go right beside each other. Yes?
So if you have a try and it doesn't throw an error, is it just as if that code is just executed something?
That's exactly right. Yep. So it's just saying try all of this stuff and try up until the point to where you can't try any further and then catch it if something happened. It's a very easy thing to do.
So this is essentially what our compiler does when we hit compile and it kicks out a bunch of errors. It's trying them out.
No, it's terminating.
Okay.
And just spitting out a core dump of your memory. You mean when you have a runtime one or when you have a syntactical?
Like a syntactical or stuff like that.
No. Okay. Because your compiler's written in C. Yes, it is handling those errors, but it's handling it through linguistics. And if you were a CS person, I'd love to see you in my 480 class where we could talk more about that, but I don't want to lose everybody.
Okay.
But it's based on the language.
Gotcha.
Linguistics. It's really pretty cool. Does anybody know who had some of the biggest influence in our field? Who is probably the one biggest, I think is one of the biggest influencers in our field? Is not even a computer scientist. Do you know who it is? Who is it, guys? Anybody a poli-sci person or history or linguistics? Chomp.
Oh, Noam Chomsky.
Noam Chomsky, good job. Noam Chomsky. One of the biggest, we would not have a language. You would not be writing software if it weren't for him. Thank Noam Chomsky. It's linguistics. Comes out of, we're really tied a lot to philosophy in that area. Linguistics, philosophy. It's kind of cool. We could go there some other time. But anyway, go have fun. Enjoy your day. That's it. There's no more to this, okay? Yeah.
So, like, I almost get to figure it out my assignment. So, like, pretty much I understand. I know how to do the background stuff.
Oh, hold on. Let me stop this so that people don't have to hear me going on and on. I forget to stop.